Today we are here with the Module 1 of the Chapter 1, that is Units and Measurement. So let's begin this module. First of all, we have the need for measurement. What is the need for measurement? Okay, we know that the measuring tape is used to measure the lengths. The ruler is used to measure the small lengths in millimeter, centimeter or inches. The thermometer is used to measure the temperature. A balance scale is used to measure the mass. So these are the tools or devices which are used to measure the things. So we can say that physics is the science of measurement. The measurement determines an object's mass, length, capacity, size, or other physical dimensions. It enables us to represent a physical quantity in numbers. So these are the things why we need for measurement. Okay, moving ahead, we have the units of measurement. All right, what here? We have a bar over here that we need to measure. The length of the bar we need to measure with the help of a ruler. So here we place a ruler and it says it is at 5, from 0 to 5. So we will say that the measurement is 5 centimeter. This 5 is a numerical value. This centimeter is a unit. So we can say that the measurement of a quantity requires a numerical value and a unit. All right, so these are the two things that we need for the measurement. All right, for example, 5 kilogram. In this measurement of mass, that is 5 kilogram, 5 is the numerical value and kilogram is the unit. In the measurement of time 30 seconds, 30 is the numerical value and second is the unit. Moving ahead, we have the system of units. All right, so here are some system of units that we are going to discuss. All right, first one is the CGS system. CGS system. All right, CGS stands for centimeter, gram, second. Okay, so it is a system of units in which the length is measured in centimeter, the mass is measured in gram, and the time is measured in second. That is called CGS system. Moving ahead, we have next system of units, that is FPS system. In this system of units, what we do, what here? FPS stands for foot, pound, second. So we will say that in the system of units, the length is measured in foot, the mass is measured in pound, and the time is measured in second. So this system of units is called FPS system. Moving ahead with the next system of units, that is MKS system. All right, MKS stands for meter, kilogram, second. So in this system of units, the length is measured in meter, the mass is measured in kilogram, and the time is measured in seconds. So this system is called MKS system. Moving ahead with the next system of units, that is SI. SI stands for, it is a French term which is Système International de Units, and in English it is International System of Units. And this system of units is based on the 7 fundamental units and 2 supplementary units. What are these 7 fundamental units and supplementary units? We will discuss over here. Watch here. The SI units we are going to elaborate. So SI units consists of some fundamental units. There are 7 fundamental units. What are these fundamental units? Let's discuss. So the first one is length. The name of the quantity is length. It is measured in the unit meter and the symbol is m. The next fundamental quantity is mass. The quantity is mass measured in the unit kilogram and the symbol is kg. The next fundamental quantity is time measured in the unit second with the symbol S. Next fundamental quantity is temperature measured in the unit Kelvin and the symbol is K. Next is luminous intensity measured in the unit candela. The symbol is CD. Next is electric current measured in the unit ampere. The symbol is A. Next and the last is the amount of substance measured in the unit mole and the symbol is MOL, mole. Okay, so these are the units which we call as fundamental units. These are the fundamental units and these quantities are termed as fundamental quantities. About fundamental quantities we will discuss later. Okay, right now we are discussing the fundamental units. These are the fundamental units. Moving ahead, some more about the fundamental units. The first one was length. What is length? Length is the separation between 2 points. Between any 2 points, the separation we can say as length. And the mass. What is the mass? The quantity of matter a body contains is called its mass. Next one, time. The duration between 2 events. The duration between 2 events is called the time. The starting time or the end time. The duration between those 2 events we say as time. And the temperature. The degree of hotness or coldness is called temperature. Now, the luminous intensity. The measure of light emitted from a light source is called luminous intensity. Now, the electric current. The rate of flow of charge is called electric current that you have learned in class 10th. Alright, the next one and the last, the amount of substance. So, this is the number of particles in a substance is called the amount of substance. Moving ahead with the supplementary units, there are 2 supplementary units under SI units, which are, first one is plane angle. The quantity is plane angle measured in the unit radian and the symbol is RAD, rad. The next supplementary unit is solid angle. Solid angle measured in the unit steradian. The symbol is SR. Now, what are the supplementary units imply? Watch here. Plane angle. The angle at the center of a circle is called plane angle. The angle at the center of the circle is called plane angle, while the angle at the center of a sphere is called solid angle. Alright, this is a circle. The angle at the center of the circle is called plane angle. This is a sphere. The angle at the center of the sphere is called solid angle. Alright, now moving ahead, we will discuss about fundamental quantities. What are fundamental quantities? Let's discuss. So, the quantities which are independent and cannot be derived from other are called fundamental quantities. For example, length, mass, time. These quantities are independent and cannot be derived from each other. Length cannot be derived from mass or any other quantity. Mass cannot be derived from length or time or any other quantity. Time cannot be derived from length or mass or any other quantity. It means these quantities are independent and cannot be derived from the other quantities. So we will say these are fundamental quantities. And the units of the fundamental quantities are called fundamental units. Now let's talk about the derived quantities. What are derived quantities? Let's see. The quantities which are dependent and can be derived from the other quantities are called derived quantities. So, for example, speed, force, work, etc. The units of derived quantities are called derived units. Watch here. Speed is a derived quantity, force is a derived quantity, and work is a derived quantity. Why these quantities are derived quantities? Watch here. Since we know that speed is distance traveled upon time, it means speed depends upon distance and time. Speed depends upon two other quantities. So, speed is dependent upon two other quantities or derived from these two quantities. When we divide distance by time, then we get speed. It means speed is derived from distance and time. So, we will say that speed is a derived quantity. Next thing, force is given as mass into acceleration. Force depends upon two other quantities, mass and acceleration, or we can say force is derived when we multiply the mass and acceleration. The force is derived from mass and acceleration, so the force is a derived quantity. Next thing, work. Work is given as force into displacement in the direction of the force. So the work depends upon force and displacement. Work is derived from the force and the displacement. So we will say the work is a derived quantity. Now let's talk about accuracy. We will illustrate the accuracy with the help of an example. So watch here. An archer is aiming towards a target like this, and all the arrows he is trying to aim nearby the bullseye. Bullseye is the center of the target, that is the green one. You can see here he is aiming the targets nearby the bullseye. And each arrow is getting a point for the target. So these were the arrows the archer aimed on the target, and all the 5 arrows are representing the closeness towards the bullseye. All these 5 arrows are representing the closeness to the bullseye. So we will say that the measurement achieved by these arrows is accurate. So this closeness is called accuracy. Watch here. The closeness of the measurements to a specific value is called accuracy. So the closeness is specifying the accuracy, and these measurements are accurate measurements, and that specific value is the bullseye, means the green one, and the data achieved is here. Watch here. Here the true value is 10 units. 10 units is given for bullseye. 10 units is given for the center of the target, that is the green one. All right, you can see here at the center, the green one, which is called the bullseye. The 10 units is awarded for aiming at the bullseye. So the true value is 10 units. And what are the measured values with the help of these arrows? Watch here. The measured values are M1, that is for the first arrow, which is 8.2 units. M2, that is for the second arrow, which is 9.2 units. M3 for the third arrow, which is 9.0 units. M4 is for fourth arrow, which is 9.5 units. And M5 is for fifth arrow, which is 9.1 units. All these measured values are representing the closeness to the true value, that is 10 units. All these measurements are representing the closeness to the true value. So we will say that this closeness is called accuracy, and our data is said to be accurate. Now moving ahead with precision. What is precision? We will illustrate with the help of an example. Watch here. Again, an archer is aiming towards a target, but in this case he is aiming far away from the bullseye. You can see here, far away from the bullseye. All the arrows he is aiming far away from the bullseye. And you can see the points. You can watch here the measurements or the points achieved while aiming at the target. So you can see here the target, all the 5 arrows on the target, you can see here. Watch this. So these targets are far away from the bullseye. But one more thing you have to notice, that these arrows are very close to each other. These arrows are very far away from the bullseye, but with each other these are very closed. Or we can say there is a repetition of the arrows on the nearby values. Listen, all the arrows are very far away from the bullseye, but there is a repetition at that value where all the arrows are aimed. There is a repetition of the aim. So this repetition at the same value or a little bit different values is called precision. You can see here the repetition of the arrows is called precision. So the repetition of the measurements is called precision. The measurements are precise measurements. These measurements which are repeating their values are called precise measurements. So you have to notice here that there is no closeness to the bullseye. These are very far away from the bullseye, but there is a repetition of the values. That's why we are saying that these values are precise values. Okay, now take a look at the data achieved with the help of these arrows. Again, the true value is assigned for 10 units, that is bullseye, and our measurements for the first arrow, that is M1, is 2.0 units. For the second arrow, that is M2, is 1.6 units. For the third arrow, that is M3, is 1.7 units. For the fourth arrow, that is M4, is 2.0 units. For the fifth arrow, that is M5, is 2.0 units. So you can see here all these values are approximately equal to 2 units. Approximately equal to 2 units. So these are repeating the value approximately equal to 2 units. So we will say there is a repetition of the data, and 3 times for M1, for M4 and for M5 there is exact value, that is 2.0, and M2 and M3, these are 1.6 and 1.7, which are approximately equal to 2 units. So we will say there is a repetition of the values on 2 units. And one more thing you need to notice, there is a very big gap from the true value and the measured values. So in case of precision, it does not care about the closeness to the true value. It only cares about the repetition of the values, and here we can clearly see the repetition of the values that is nearby 2 units. So we will say that this data is precise and these values are precise. Now moving ahead, we will see the accuracy and precision together. Is it possible that we can say accuracy and precision together? Yes, it is possible. We will illustrate this with the help of an example. Watch here. Again, this archer is aiming towards the bullseye. Now let's watch it. Exactly at the bullseye. And it is giving the 10 points for that. Again, our archer is becoming so good. And it is aiming exactly at the bullseye. Again, 10 points. Nearby 10 points, of course, that can be counted as 10 points. And this is getting again 10 points, but it is out from the green zone. So we will give that 9.8 or 9.9 like that. It is again 10 points. Okay, so here you can see the values. Watch here. 3 arrows are exactly at the bullseye within the green zone. 2 arrows are out from the green zone, but they are giving the 10 points, but I want to give them 9.9 and 9.8 because that is the exact value we are talking about here. So only within the green zone we will say as 10 units. So and watch here, you can see 2 things we can see here. One thing is all these arrows are representing the closeness to the bullseye. Some of the arrows are exactly at the bullseye, means here is a very high closeness of the measurements to the true value, very high closeness of the arrows to the bullseye. So we will say it is very highly accurate data we are achieving here. And the second thing, these arrows are repeating their values. All these arrows are repeating their values. All these arrows are nearby 10. Watching here, all these arrows are repeating their values. We can see here a repetition. Both things we can achieve here. Here we can see the closeness to the bullseye and we can see the repetition of the arrows. So both things are implied here, accuracy as well as precision. These data is accurate as well as precise. This data is accurate as well as precise. So in this case, take a look at the data. Watch here. Again, here true value is 10 units, that is for the bullseye, and for our arrows the data achieved is M1 for the first arrow, which is 10.0 units, exactly at the center of the bullseye, very high achievement. M2 was again at the center of the bullseye. M2 for the second arrow, that is again 10.0 units. M3 for the third arrow, that was a little bit outer from the green zone, we are giving that 9.9 units. M4 was a little bit more far from the bullseye, so we are giving that 9.8 units. That is for the fourth arrow. And for the fifth arrow, that was again within the bullseye, again within the green zone, we are giving that 10.0 units. So you can see here the measured values are repeating themselves. The measured values are representing a repetition, and as well as these measured values are closer to the true value, closer to the bullseye, at the bullseye. So we can see here accuracy as well as precision. So these both factors can be seen here, accuracy as well as precision. So we will say that this data is accurate as well as precise. These measurements are accurate as well as precise. So that's all for now. See you again. Thank you.